All right, welcome back to the effect. We are still talking about heterogeneous treatment effects. The idea that the same treatment might have different impacts on different individuals, right? Which seems like a pretty reasonable thing to assume. When this happens, if we are taking an approach where we are still reporting just a single estimate of what the effect is, then we have to think carefully about, well, the effect for who? Right? And in general, we are talking about some sort of aggregated treatment effect where each individual has their own treatment effect, and whatever estimate we are producing is averaging them together in some way. We talked about the average treatment effect, which is the simplest one. It just literally averages everybody. And in this video, we're going to be talking about what are called conditional average treatment effects. And a conditional average treatment effect is the average treatment effect, still the average treatment effect, but it's the average treatment effect among some group. So conditional on being in some certain group, then we are estimating the average treatment effect among that group, right? Conditional average treatment effect. So to see what I mean, let's take an example of some hypothetical data. Now, to be clear, this is not the kind of data you could ever actually have, because I'm going to show you a table that has some outcomes for people, both if they got treatment and if they did not get treatment, right? Which we could not actually know in real data. So we have 4 people here, 4 different sort of types of people. I've given them names, but really these are sort of categories of people, not individual people. So we got Alfred. Alfred is male. If Alfred did not get the treatment, he'd have an outcome of 1. If he does get the treatment, he gets an outcome of 2. So his individual treatment effect is positive 1. The treatment increases his outcome by 1. We got Brianna, who is female. If she is untreated, then she gets an outcome of 1. If she does get treated, then she gets an outcome of 5. So the treatment is more effective for Brianna than it is for Alfred. It increases her outcome by 4. We got Chizu, who is female. If Chizu is untreated, then she gets an outcome of 2. If she is treated, she gets an outcome of 5, so her treatment effect is 3. And we got Diego, who is male. If he is not treated, he gets an outcome of 2. If he is treated, he gets an outcome of 4, so his treatment effect is 2. So we could also, of course, think of the average treatment effect for this group. Their treatment effects are 1, 2, 3, and 4. If you average those out, you get 2.5 as the average treatment effect. So let's see what happens if we get a conditional average treatment effect, or a treatment effect among only one group. So we have in our sort of typical data here, we have both men and women, males and females. But what if we ran some sort of randomized experiment, but we only recruited men into our experiment? So in that case, the Briannas and Chizus would be gone, and we'd only get some Alfreds and Diegos. Now, based on a random assignment, some of those Alfreds would be treated and some would be untreated. Some of the Diegos would be treated and some would be untreated. And we would see the outcomes that they would get from that. Now, if we look at this table, we can see that the average outcome among people who are treated is the average of 2 and 4, which is 3. The average among the untreated people is 1.5. So the difference between the treated groups and the untreated groups is 1.5, so we get a treatment effect of 1.5. And we can say, well, what does that represent? Well, that should be the average treatment effect among men, because we randomized among just men. The treatment effect for Alfred was 1, the treatment effect for Diego was 2, the average of those two numbers is 1.5, which is the exact number that we got. By randomizing among a particular group, we got the treatment effect among just that group, right? Now this could be good, maybe if we're talking about the cervical cancer drug from the last video, we probably only want to randomize among people who do have a cervix, because we want to know the effect among that group. Who cares about the effect on cervical cancer among people who can't get cervical cancer? Doesn't matter, right? It could be not what we want. And those psychology studies that I mentioned, where they are looking at a random sample of just college students, but they want to say something about the general population, that's not so good, because you're getting the conditional effect among college students, but you want an effect among a broader population. So this could be good or bad depending on the context. That brings us to our second rule of thumb, by the way. In the first video, I mentioned that the first rule of thumb for getting a treatment effect average and figuring out what your estimate actually means is that if you randomize in a representative population, you get an average treatment effect. Well, in this case, if we randomize among a selected population, then we get a conditional average treatment effect. That's rule of thumb number 2, that we are getting the average treatment effect among that group that we have selected in which we have randomized. So if we do that psychology study just among college students, then we get an average treatment effect, but it is a conditional average treatment effect, conditional on being a college student. And this can be the case whether you are picking a sample of people and then randomizing in that group, or if you happen to find in the real world a source of randomization that only applies to a particular group, and then you use just that group. As long as there's randomization within a group, you're getting a conditional average treatment effect for that group. Another kind of common conditional average treatment effect is one where the group, the thing that you are conditioning on, is not so much a thing about who you are, but rather it's about whether or not you were treated. These are two different kinds of conditional average treatment effects. The average treatment on the treated, which is the average treatment effect among people who actually did get treated, and the average treatment on the untreated, which is the average treatment effect among people who did not get the treatment, as in how effective would the treatment have been for this group if indeed it were applied to them. Now, these are both important to think about, and you can get both based on the kinds of estimation that you do. I'm going to focus here on the average treatment on the treated because it comes up a bit more often. So average treatment on the treated, as I mentioned, is the average treatment effect among people who were actually treated. Let's see how we could get an estimate sort of like that. So let's take those same 4 individuals from before, and let's instead of randomizing them directly, let's just say that we happen to observe that Alfred and Chizu get treated, and Brianna and Diego do not get treated. Now, something that you might note if you do this is that based on what we know about their untreated outcomes, if we happened to observe all of them without getting the treatment, the average outcome for both the treated and untreated groups would be 1.5, because the average untreated outcome for Alfred and Chizu is 1 plus 2 divided by 3, which is 1.5. The average untreated outcome for Brianna and Diego is 1 plus 2 divided by 2, which is 1.5. So there's no back doors here, right? The average outcomes, if the treatment had not occurred, are the exact same between the treated and untreated groups. So we're probably pretty good to be able to say, okay, if we just look at the difference between the treated outcomes and the untreated outcomes, that gives us a pretty good idea of what the effective treatment is, right? Because the untreated outcome is the same for both of those groups. So I can make that comparison pretty easy between the treated outcome of who actually got treated against the untreated outcome of the people who did not actually get treated, because I think that these two things are the same, right? Because I think the untreated outcomes are the same. Now, if I do that, what do I get? I can end up looking at the treated outcomes for Alfred and Chizu, the people who actually got treated. The average outcome for them is the average of 2 and 5, which is 3.5. If I look at the untreated outcomes, the average of 1 and 2 is 1.5, just like we had it before. Now, if we look at the comparison between these things, we do 3.5 minus 1.5 to get an effect of 2. Now, this 2, what does this 2 represent? This should be an average of the treatment effects among the people who actually got treated. Alfred's individual treatment effect was 1, Chizu's individual treatment effect was 3. You average those out, you get 2, which is the exact number that we got, right? Remember, without actually seeing any of the individual treatment effects, the single estimate that we got, 2, was indeed an average of those individual treatment effects we couldn't see among the treated group. That's what I mean by the estimate that we've produced. The single estimate represents an average of individual treatment effects, even though we can't actually see those individual effects. So when is an average treatment on the treated likely to come up? This brings us to rule of thumb number 4. And if you're thinking, wait a minute, what happened to rule of thumb number 3? Well, I'm following the book order, and the book order doesn't go in the way that lines up with the videos very well. But we'll come to 3 in the next video. So rule of thumb number 4, if you're doing some sort of estimate where you're using some sort of control group as a indication of what the treated group would have looked like without treatment, then you are going to likely get an average treatment on the treated effect. Because what are you doing here, right? You're saying, hey, this group got treated. I'm going to compare them to what they would have been like untreated. I have an estimate of what they would have been like untreated, and that's the comparison that I'm making. And this is really talking about how is this treated group different from what I think they would have been without treatment, right? Which naturally is going to give us an average treatment on the treated effect. So as I mentioned, there's also the average treatment on the untreated. How do you get that? Well, the process for that's a bit more involved. You have to do some adjusting to try to figure out how can I take the treated outcomes that I do see and sort of translate them into what I think the treated outcomes would have been for the untreated group. It's sort of like the flip idea. If you take the treated group's outcomes and take them as an indication of what would have happened to the untreated group if they did get treated, you get an average treatment on the untreated. If that's a little convoluted, I'd say read the book. But in general, that is how we can understand these sorts of estimates as coming about. Now, one last thing before we go. I mentioned in the last video that an alternate approach to trying to take a single estimate and interpret what it means, what kind of average it is, you can try to just estimate an individual treatment effect for each individual person. Now, that is, most of the time, just a fancy application of a conditional average treatment effect. So I mentioned a conditional average treatment effect as being like, hey, you take a group of people and you get an average treatment effect for that group. But you can also do some statistical things to do stuff like, okay, I think that the average treatment effect among this group is one thing and this group is another thing, and and all these grouping types are overlapping in really weird and intricate ways, and I'm going to use that intricate mass to sort of estimate what an individual person who fits in a particular subset of categories, what their group's individual treatment effect is, and then apply that as their individual treatment effect. So that is how a lot of different approaches that do estimate individualized treatment effects actually work. They're really just complex conditional average treatment effects, where they take all the different groups that you sit in, and they try to figure out, well, what is the treatment effect for that particular interlocking set of groups? And that's where your individual effect comes from. So it's something like conditional on being a man, being over 35, being brown-haired, living in France. All these sorts of groups come together to get and we take the effect for that group of people and apply that to your individual effect. That's how most of those approaches actually work, which we'll get to in a while. There's one more approach that we're going to take to looking at treatment effects, and that is weighted average treatment effects, and that's something we're going to look at in the next video. Hope to see you there. Bye-bye.